let's consider a scenario. We have, say, a stick with a height of, say, h. Some guy is standing away from it, and he wants to know how far away he is. So basically the distance between him and the base of the pole. So this is what we're trying to find. Of course, he can just walk across towards the pole and measure the distance. Or we can use trigonometry, because as you can see, when we join the top of the pole to where the man is standing, we have a triangle, and more specifically a right angle triangle. And if the angle of elevation here, so how far he has to look up to be looking at the top of the pole, the angle of elevation, then in relation to this angle here, the distance we're trying to find is the adjacent side, and the height of the pole becomes the opposite side. And if you recall your trigonometric ratios, the opposite side over the adjacent side is the tangent of theta. And so all we have to do to find the adjacent side is simply rearrange this equation here to turn adjacent side into the subject. So we just have to do some basic algebraic manipulations. So we end up with opposite side equals to tan theta times adjacent, and one more step, divide by tan theta, divide by tangent of theta, and we end up with opposite over tangent theta equals to the adjacent side. So here, a simple equation showing how you derive the adjacent side from the height and the tangent of a known angle. This method is actually used extensively in sea navigation, where landmarks, important landmarks, and the navigational aids were often marked on a map with a height. So, for example, let's say this map of the North Odessa lighthouse. As you can see, the height is given for 56 meters. So, the height is given. All you have to do is measure the angle of elevation, and you can estimate the distance away from the lighthouse. We have used a height to find the distance, but the inverse is also true. We can also use the known distance to find the height. So for example, let's say there is a building. And some guy is standing a distance away from it. He knows the distance, he knows how far away it is. So he's the distance away from the building, and he wants to know the height. Of course, once again, we join the top of the building with where the guy is standing, and we now have a right angled triangle. Once again, of course, height over distance is the tangent of this angle phi. And to find the height, of course, all we have to do is some very simple algebraic manipulation. We multiply both sides by d, and h is tan of phi times d. And that is all there is to it. Well, tangent is not the only trigonometric ratio that can be used this way. Sine and cosine works as well. So let's say this example. Suppose we have a wall. A guy standing away, he knows the distance here is, the perpendicular distance to a point on the wall. Let's say 10 meters. And then he turned 30 degrees. And now looking at a new point on the wall. Okay. He wants to find out what the distance between him and the second point is. And once again, we can use trigonometry. As you can see, in relation to this 30-degree angle, the new distance, let's call it d, is in fact the hypotenuse. And the original distance here is of course, the adjacent side. And if you recall your trigonometric ratios, adjacent over hypotenuse is the cosine of the angle, yeah? So in this case, adjacent side is 10 meters, the hypotenuse is d, and the angle is 30 degrees. That's all you have to do. And through some algebraic manipulations, apologies, times d, and then 10 equals to cosine 30 times the d, and to eliminate 30 degrees here, we divide both sides by cosine 30, and of course d equals to 10 over cosine 30, okay? Which works out to approximately 11 something something something. That's pretty much it.